In July 2026, the British government announced that it was finally going to touch one of the most feared shipwrecks in Europe. Not the bombs. Not the cargo holds. Not the broken hull resting beneath the Thames Estuary. Just the 3 rusting masts that still rise above the water. For 82 years, those masts had marked the grave of the SS Richard Montgomery, an American liberty ship that ran aground near Sheerness during the Second World War. From the coast, they looked almost harmless. 3 thin lines against the sky. A familiar landmark. Something local people had seen for generations. But beneath those masts lay approximately 1,400 tons of wartime explosives. The government said the risk of a major explosion was remote. It also maintained a legal exclusion zone around the wreck. It watched the site by radar 24 hours a day. It surrounded the wreck with warning buoys. It surveyed the hull repeatedly with sonar. And now it was preparing to spend millions of pounds constructing an underwater platform so specialist engineers could cut away the masts without disturbing what remained below. That creates the first question. If the ship is safe enough to leave on the seabed, why has Britain been watching it for more than 8 decades? And if the cargo is too dangerous to remove, what happens when the ship holding it finally disappears? The Richard Montgomery is not hidden in the middle of the Atlantic. It lies about 1.5 miles off Sheerness, near busy shipping routes, industrial facilities, towns, ports, and the approaches to London. Thousands of vessels pass through the wider estuary every year. People live within sight of the wreck. The war ended in 1945. The crew went home. The ship never completed its final journey. The bomb stayed. And in September 2026, engineers are expected to approach the wreck more closely than almost anyone has in years, not to make the cargo safe, but to remove the last pieces of the ship that remain visible above the sea. Why only the masts? Why now? And what exactly is still down there? The ship beneath the Thames did not begin as a legend. It began as a solution. In 1943, the United States was producing cargo ships at a speed that would have seemed impossible before the war. German submarines were sinking Allied shipping across the Atlantic. Britain needed food, fuel, weapons, vehicles, machinery, and raw materials. The Soviet Union needed supplies. American forces were preparing to move across oceans on a scale no country had ever attempted. The answer was the Liberty ship. Liberty ships were not designed to be elegant. They were designed to be built quickly, loaded heavily, and sent into danger. More than 2,700 were constructed during the war. Shipyards used standardized plans, prefabricated sections, welded hulls, and industrial production methods that turned shipbuilding into something closer to an assembly line. The SS Richard Montgomery was one of them. She was built in Jacksonville, Florida, by the St. Johns River Shipbuilding Company. Her construction took only months. She was launched in June 1943 and entered service as part of the immense transatlantic supply machine that kept the Allied war effort moving. Think about what that means. A ship built beside the St. Johns River in Florida would cross the Atlantic carrying the material needed to liberate Europe. American factory labor, British maritime control, Canadian convoys, naval escorts, port workers, soldiers, and merchant seamen all became parts of one machine. The Richard Montgomery was not famous. She was not a battleship. She did not carry admirals or presidents. She was a cargo vessel. But cargo ships often decide wars quietly. Armies cannot fight without ammunition. Aircraft cannot bomb without bombs. In August 1944, the Richard Montgomery was loaded with thousands of tons of munitions and sent toward Europe. The voyage should have made her one more anonymous success in the Allied supply chain. Instead, she became the shipment Britain could never finish unloading. The name Richard Montgomery carried its own historical irony. Richard Montgomery was an Irish-born soldier who had served in the British Army before joining the American Revolutionary Corps. He became a general in the Continental Army and was killed during the failed American assault on Quebec in 1775. More than a century and a half later, an American ship bearing his name sailed to support Britain and the liberation of Europe. A man who had died fighting British power became the namesake of a vessel carrying American bombs through British waters. That is the kind of historical detail the Thames Estuary seems to collect. The ship itself was enormous by ordinary human standards, but ordinary by wartime standards. Roughly 440 feet long, built from steel plates, divided into cargo holds, and driven by a simple engine designed for reliability rather than speed. Liberty ships were workhorses. They crossed dangerous waters in convoys, often carrying more explosive material than any city would willingly store in one place. The Richard Montgomery completed earlier voyages. Then came the summer of 1944. Allied forces had landed in Normandy in June. By August, they were pushing through France. Cherbourg had been captured and was becoming a critical supply port. The armies advancing across Europe consumed ammunition at a staggering rate. Every artillery barrage, air mission, demolition charge, and battlefield resupply depended on ships arriving from across the Atlantic. The Richard Montgomery was loaded for that effort. Official British background information describes a cargo of around 7,000 tons of munitions. Other historical records use different totals, partly because wartime manifests, explosive content, bomb casings, detonators, and recovered cargo can be counted in different ways. But no version of the story makes the load small. The holds were packed with war. And the ship was heading toward one of the busiest and most dangerous logistical systems on Earth. The voyage across the Atlantic was part of convoy HX 301. Convoys were an answer to the German U-boat threat. Merchant ships traveled together under naval protection, sacrificing speed and convenience for survival. Each ship had to maintain position, follow instructions, respond to signals, and trust that the system would carry it through. By August 1944, the Battle of the Atlantic had shifted heavily in the Allies' favor, but the ocean was never routine. A munition ship remained a vulnerable floating magazine. A torpedo, collision, fire, or mechanical failure could destroy the vessel and everyone near it. The Richard Montgomery reached British waters. That should have been the dangerous part completed. She entered the Thames Estuary and waited for the next stage of the journey, a convoy that would carry her across the Channel toward Cherbourg. The estuary was crowded with shipping. War had turned the waters near London, Kent, and Essex into a controlled highway of merchant vessels, naval movements, anchorages, pilots, harbour authorities, and convoys waiting to form. The ship was directed toward the Great Nore anchorage near Sheerness. This is where the story narrows from global war to a single local decision. A ship drawing deep water was told where to anchor. The margin beneath her keel was small. The weather worsened. The tide changed. The anchor dragged. And the vessel carrying thousands of tons of explosives began moving toward a sandbank. Other ships may have noticed the danger before the Richard Montgomery's own officers fully reacted. Signals and warnings became part of later accounts. But by the time the crew understood what was happening, the ship had already crossed from navigation problem into disaster. On August 20, 1944, she grounded. The convoy continued preparing to cross the Channel. The cargo ship stopped forever. Grounding does not sound dramatic. Ships touch bottom. Tugs pull them free. Cargo is shifted. The tide rises. Many vessels survive. But the Richard Montgomery did not settle evenly. She came down across the crest of a sandbank, supported near the middle while the bow and stern remained exposed to the weight of the cargo and the movement of the water. As the tide fell, the ship's own mass began working against her. Steel groaned. Plates buckled. The hull strained. This was a Liberty ship built quickly for a war that demanded numbers. The design had strengths, but welded ships of the period could suffer structural cracking. Cold water, stress concentration, heavy cargo, and poor support could turn a small fracture into a catastrophic break. The crew understood the danger. A ship full of bombs was now stuck in shallow water near one of Britain's major maritime arteries. If fire began, if detonators were triggered, or if the hull failed violently, the accident could become an explosion with consequences far beyond the ship. The crew left. That detail matters. The Richard Montgomery did not sink in deep water with sailors trapped below. There was time to act. There was time to begin salvage. There was a chance to save the cargo. The ship was not lost instantly. It was lost slowly. And slow disasters can be worse because every stage creates another decision. Do you unload faster? Do you wait for safer conditions? Do you risk workers inside a cracking hull? Do you move the ship? Do you abandon it? The questions of August 1944 are still the questions surrounding the wreck today. Every option carried danger. Doing nothing carried danger too. Salvage began quickly. The ammunition was desperately needed in Europe. It was also too dangerous to leave aboard a damaged ship. Stevedores and salvage workers started unloading the holds, moving bombs and other munitions from the wreck to smaller vessels. Imagine the work. A grounded ship shifting with the tide. Steel under strain. Cargo holds packed with explosives. Workers descending into spaces that might flood or collapse. Each item had to be handled without impact, fire, or panic. The ship's own cargo gear was used while it remained available. The salvage operation continued for weeks. Approximately half the cargo was removed, according to the official British account. That was a remarkable achievement. But the hull kept deteriorating. A crack appeared. The forward section began flooding. The ship's back eventually broke. Water entered spaces that salvage crews still needed to reach. The deck, hatches, winches, and lifting routes became less reliable. The operation that began as urgent recovery became a judgment about how many lives Britain was willing to risk for the remaining bombs. By September 25, the effort was abandoned. That date created the Richard Montgomery problem. The recovered cargo went on to serve the war effort or was disposed of elsewhere. The unrecovered cargo stayed inside the forward holds. The wreck settled into the sandbank. The sea moved around it. The broken ship became part of the estuary. No one in 1944 was making an 80-year plan. They were making an emergency decision in the middle of a world war. Leave it for now. Return later. Find a safer method. But later kept moving. The war ended. Technology changed. Governments changed. The bombs remained where the salvage workers left them. What exactly remains aboard the Richard Montgomery is one of the most important and most misunderstood parts of the story. The official figure repeated by the Maritime and Coast Guard Agency is approximately 1,400 tons of explosives in the forward holds. That number refers to explosive content, not simply the total weight of metal bombs, casings, packaging, racks, and other material. Historical manifests list thousands of individual items. The remaining cargo is generally described as aircraft bombs and other munitions, including high explosive weapons of different sizes. Some historical accounts also discuss fuses, detonators, and phosphorus-filled devices. Over decades, corrosion, movement, burial, and structural collapse have changed the physical arrangement. This uncertainty feeds sensational headlines. Some writers compare the wreck to a small nuclear weapon. Others describe a blast wave reaching London. Some predict a giant wall of water. Those comparisons are often misleading. A cargo of old conventional bombs is not a nuclear device. The munitions are distributed through damaged holds, exposed to water, corrosion, and sediment. Whether one item could trigger others depends on condition, spacing, confinement, sensitivity, and the exact sequence of events. A theoretical simultaneous detonation is not the same as the most credible real-world scenario. The British government's position is that the risk of a major explosion is remote. But remote does not mean impossible. And 1,400 tons is not a figure governments ignore. This is why the wreck is monitored rather than forgotten. The danger is difficult to describe because it sits between two misleading extremes. The Richard Montgomery is not expected to explode tomorrow. It is also not an ordinary shipwreck. Seawater does not automatically make every explosive safe. That assumption is one reason the wreck fascinates people. Many imagine that decades underwater must have neutralized the cargo. In reality, prolonged immersion can damage munitions in complicated ways. Casings corrode. Fuses deteriorate. Explosive compounds may change. Some components become less functional. Others can become unstable under certain conditions. The exact condition of each item cannot be inspected easily. The holds are not a warehouse with neat shelves and clear aisles. They are parts of a broken, corroding ship buried in mud and exposed to tides. Bombs may have shifted. Decks may have collapsed. Sediment may cover some cargo. Metal structures may press against objects that were once separated. The water is dark. Visibility is poor. The current is strong. That is why modern surveys rely heavily on sonar rather than sending divers into every part of the wreck. Sonar can show the shape of the hull, changes in the seabed, the angle of masts, and visible structural deterioration. It cannot tell engineers everything happening inside every bomb. The uncertainty is physical. It is also philosophical. Is a weapon safer because it has been underwater for 80 years? Or more dangerous because no one can be certain what 80 years has done? The honest answer is that different components may behave differently, and risk must be managed through evidence, modeling, monitoring, exclusion, and caution. That is less dramatic than calling the wreck a ticking time bomb. It is also more unsettling. A ticking clock tells you when something ends. The Richard Montgomery has no clock. The wreck lies near the Medway approach channel, close to routes used by ships moving through the Thames and Medway estuaries. That location is the reason the story never becomes only archaeological. If the Richard Montgomery were at the bottom of a remote ocean trench, monitoring would be simpler. But the site sits near Sheerness, Southend, the Isle of Grain, ports, energy infrastructure, commercial shipping, and communities that have lived with the wreck for generations. The masts became familiar. Children saw them from the shore. Fishermen learned the boundaries. Pilots and harbor authorities knew the exclusion zone. The wreck became part of local geography, a forbidden point in the water that everyone recognized but few could approach. There is something psychologically strange about living beside a hazard that almost never changes. A siren is frightening because it is sudden. The Richard Montgomery is frightening because it is permanent. People adapt to permanent danger. They make jokes. They use nicknames. They watch documentaries. They argue about whether officials exaggerate or minimize the risk. New residents learn the story. Older residents remember earlier surveys and previous promises. The wreck becomes normal. Then the government announces a major engineering operation, and the normality breaks. In 2026, the masts are no longer simply a landmark. They are a structural concern. Their weight may place strain on the deck plating. If a mast collapses into the wreck, it could damage the hull or disturb cargo. So Britain will remove the visible warning while leaving the invisible danger. The skyline will become calmer. The seabed will not. The exclusion zone around the Richard Montgomery is not symbolic. The wreck is designated under the Protection of Wrecks Act. Buoys mark the restricted area. Warning signs are attached to the masts. The site is monitored by radar. Unauthorized entry can trigger a response from port authorities. This level of protection answers one question and creates another. If the explosion risk is remote, why prevent people from approaching? Because remote risk can still be unacceptable when the consequences could be severe. A small recreational boat anchoring over an ordinary wreck might cause little harm. An anchor dragged through the Richard Montgomery site could strike corroded metal, disturb debris, or become caught. A collision, salvage attempt, or unauthorized dive could introduce forces the wreck has not experienced naturally. The management strategy therefore depends on controlling human behavior. Ships are kept away. The wreck is observed. Changes are measured. Intervention is minimized unless experts believe intervention will reduce long-term risk. This is a classic engineering dilemma. The safest object to touch may be the one you leave alone. But leaving it alone allows deterioration. Eventually, deterioration may make intervention unavoidable. The masts represent that threshold. For decades, they were left in place. Later, rigging and upper material were trimmed to reduce stress. Then experts recommended removing the masts themselves. Preparatory work revealed complications. The project was delayed and redesigned. Finally, in 2026, the government announced a new operation. The history of the wreck is not neglect alone. It is a series of decisions made under uncertainty. And every decision changes the next one. For decades, divers were among the few people who could directly inspect the Richard Montgomery. The work was difficult. The Thames Estuary is not clear tropical water. Visibility around the wreck can be extremely poor. Tides move sediment. Current complicates positioning. The ship's structure is corroded and unstable. The cargo makes every contact more serious. Divers could examine hull plating, cracks, seabed support, and structural conditions. But sending human beings into a hazardous wreck site has limits. A diver sees only what the light reaches. The work is slow. Touching or entering fragile spaces may create risk. By the 1990s, advances in sonar changed the monitoring strategy. High-resolution multibeam systems could map the wreck and surrounding seabed in 3 dimensions. Survey teams could compare one year's model with another. They could see where metal had shifted, where sediment had moved, where parts of the hull were losing support, and how the masts were changing angle. This transformed the Richard Montgomery from a dark object known through occasional dives into a dataset watched over time. The wreck became measurable. But measurement does not eliminate judgment. A sonar image can show a change. Experts still have to decide whether the change matters. Is the hull settling naturally? Is the seabed eroding? Is a mast placing more stress on the deck? Is debris moving toward a cargo hold? At what point does gradual deterioration become urgent? The wreck does not send clear messages. It changes by millimeters, centimeters, angles, cracks, and shadows. Engineers have to translate those changes into decisions that affect thousands of people. The British government uses a phrase that appears repeatedly in official descriptions. The risk of a major explosion is believed to be remote. That is careful language. Not zero. Not impossible. Remote. Risk has 2 parts, probability and consequence. An event can be unlikely but still demand serious management if the consequences are potentially catastrophic. Aviation, nuclear safety, dam engineering, and explosive ordnance all operate with this logic. The Richard Montgomery is an extreme example. The probability of a major detonation may be low. The consequences are uncertain but potentially severe. The wreck therefore justifies monitoring, exclusion, technical assessment, emergency planning, and selective intervention. This is why the public debate often becomes confused. One side hears remote and concludes there is nothing to worry about. The other hears 1,400 tons of explosives and concludes disaster is inevitable. Both conclusions go beyond the evidence. The more accurate picture is less satisfying. The wreck is deteriorating gradually. It is considered stable. It contains a large quantity of explosives. It is near populated and industrial areas. Experts believe a major explosion is unlikely. They also believe the site should never be ignored. That combination does not produce a dramatic countdown. It produces permanent vigilance. And permanent vigilance is expensive, politically awkward, and difficult to explain. A government cannot say the wreck is harmless. It also cannot alarm communities every time a survey finds corrosion. So it repeats the phrase. Remote risk. Monitored condition. Stable wreck. Year after year. The Richard Montgomery is often called a time bomb. The phrase is irresistible. A time bomb has suspense built into it. It suggests a device waiting for the final second. It gives journalists a headline and documentary makers an image. But the metaphor is wrong in one important way. There is no known timer. The wreck is more like an old building full of explosives slowly losing structural strength while exposed to a changing environment. The danger comes from interactions, corrosion, collapse, impact, human intrusion, seabed movement, or an event that experts have not fully predicted. That is harder to visualize. So the masts become the image. They are the part viewers can see. 3 corroded structures rising above the tide, marking cargo no camera can easily reach. They make the invisible visible. When the masts are removed, the visual shorthand will disappear. The wreck will still be on charts. The buoys will remain. Radar will continue. The exclusion zone will stay. But from shore, the bomb ship may no longer announce itself so clearly. This gives the 2026 operation symbolic weight beyond engineering. Britain is removing the monument, not the problem. The masts will be conserved at Chatham and displayed as maritime heritage. Visitors may one day stand beside them, read the story, and look at rusted steel that spent 82 years above a cargo of bombs. Meanwhile, the ship that carried them will remain below the water. History will be placed in a museum. Risk will remain at sea. Why not remove the bombs? That is the question almost every viewer asks. The simple answer is that removal may create more danger than leaving them in place. A full salvage operation would require engineers and explosive ordnance specialists to work around a fractured ship in poor visibility and strong tidal conditions. They would need to uncover, identify, stabilize, lift, transport, and dispose of munitions that have been submerged for more than 8 decades. Each step introduces movement. Movement is the problem. Bombs that have rested in one position may be corroded into racks or buried beneath debris. Lifting a deck section could shift cargo. Cutting steel could transmit vibration. Removing sediment could alter support. A tool could strike a casing. A crane could lose load. Weather could interrupt an operation after the wreck had been disturbed. This does not mean salvage is impossible. Modern explosive ordnance disposal can accomplish extraordinary things. But feasibility is not the same as prudence. Engineers compare the risk of intervention with the risk of continued monitoring. For most of the post-war period, the balance favored leaving the cargo alone. The masts changed that balance because they represented a separate structural hazard. Their weight and possible collapse could affect the wreck. Removing them is intended to reduce risk without entering the cargo holds. This is surgical intervention. Touch the part that may create future damage. Avoid the part where disturbance could create immediate danger. The bombs stay because the most obvious solution may be the least safe. There is a second reason the wreck remains in place. No government wants to own the moment risk becomes action. Monitoring spreads responsibility across years, departments, contractors, scientific reports, and technical committees. A removal operation concentrates responsibility into days and weeks. Every cut, lift, dive, and decision has a name attached. If nothing happens, the wreck remains an old problem managed by procedure. If an intervention triggers an incident, it becomes a political catastrophe. This does not mean officials are simply afraid. The caution is rational. But institutional psychology matters. Governments are often more comfortable managing chronic risk than initiating high-risk transformation. The Richard Montgomery became a chronic risk almost by accident. In 1944, salvage was abandoned because the immediate danger was too high. After the war, the cargo remained. As years passed, corrosion made future salvage more complicated. As decades passed, the wreck became part of the estuary. By the time technology improved, the cargo had aged into uncertainty. The longer the bombs stayed, the harder it became to justify touching them. This is how temporary emergency decisions become permanent infrastructure. No one chose an 80-year solution in one meeting. The solution accumulated. One survey. One review. One exclusion order. One postponed project. One cautious year after another. The ship sank quickly. The policy formed slowly. The ship's cargo was intended for Cherbourg. That destination connects the wreck directly to the liberation of Europe. In August 1944, Allied armies were breaking out of Normandy. Supply lines were under extraordinary pressure. Cherbourg's port had been damaged by German forces before surrender, and engineers worked to restore it. Every ton of ammunition mattered. The Richard Montgomery's bombs were not random surplus. They were part of the material force driving Nazi Germany out of occupied Europe. This gives the wreck a double identity. It is a hazard. It is also a war memorial. The cargo below the Thames was intended to be used in one of history's most consequential military campaigns. The ship's failure did not change the outcome of the war, because thousands of other vessels continued arriving. But the Richard Montgomery represents the scale of the logistical system behind victory. For every famous battle, there were cargo ships. For every general, there were merchant sailors. For every aircraft mission, there were bombs loaded by workers in American ports and unloaded by workers in Britain and France. The wreck is therefore not simply a mistake preserved in mud. It is a frozen piece of the Allied supply chain. A shipment paused between factory and battlefield. When the masts are displayed at Chatham, that may become the official story: Anglo-American cooperation, maritime sacrifice, and wartime logistics. But heritage does not erase danger. The same cargo that symbolizes the war effort is the reason the ship cannot be treated like an ordinary museum wreck. The Liberty ship program itself was one of the industrial miracles of the Second World War. The ships were simple by design. Standardization allowed yards across the United States to produce them rapidly. Some were completed in astonishingly short periods, though publicity records were not the norm. The important fact was not one record-setting ship. It was the total fleet. Thousands of vessels created redundancy. German submarines could sink ships, but the United States could build replacements faster than the Axis could destroy the supply system. Industrial production became a weapon. The Richard Montgomery embodied both the success and weakness of that approach. She existed because speed mattered. She also suffered inside a design culture that accepted limited service life and wartime compromise. Liberty ships were not expected to remain in exposed seawater for 80 years. Their steel, welds, decks, and masts were built for voyages, not permanent submersion. The wreck has now existed underwater far longer than the ship existed afloat. That reversal is extraordinary. The Richard Montgomery served for little more than a year before grounding. She has spent more than 8 decades as a monitored ruin. The temporary ship became a permanent object. This is why its deterioration should surprise no one. The surprising thing is that enough structure remains to survey at all. Engineers are asking a wartime cargo ship to behave like a long-term storage container. It was never designed for that job. The wreck also sits near one of the most economically important waterways in Britain. The Thames Estuary is not only the river mouth leading toward London. It is a working maritime landscape. Ports, terminals, energy infrastructure, shipping channels, industrial facilities, coastal communities, and environmental systems all share the same space. A major incident could disrupt more than one town. Even a precautionary closure could affect shipping. An exclusion zone already constrains navigation around the wreck. This is why the Richard Montgomery is not a local curiosity, even though local communities know it best. The site belongs to a national risk system. Maritime authorities monitor it. Government departments fund surveys. Explosives experts advise. Emergency services plan. Port operators watch radar. Engineers model structures. Politicians answer questions. The wreck creates an invisible network of modern work around an old piece of steel. Most days, nothing happens. That is the success condition. No headlines. No evacuation. No collision. No sudden change. Risk management is often invisible when it works. People see the buoys and assume the wreck is being ignored. In reality, the absence of drama may result from continuous observation and controlled access. But observation has limits. Radar can stop a boat from entering. It cannot stop corrosion. Sonar can measure a mast leaning. It cannot hold the mast upright. Eventually, watching becomes doing. That moment arrived in 2026. The plan announced in July 2026 is precise in its ambition. Specialist marine engineers will construct an underwater platform around the wreck. From that controlled working position, they will cut the 3 masts below sea level. The operation is expected to take several weeks, depending on weather and conditions. The masts will not be dropped onto the wreck. They will be carefully removed. Then they will be transported to the historic dockyard Chatham for conservation. The government intends them to remain in Kent as public heritage. The project is backed by £9.5 million in funding. That amount reveals the complexity of touching even the safest visible part of the ship. The cost is not simply cutting steel. It includes planning, surveys, specialist vessels, platform construction, explosive ordnance advice, environmental controls, emergency coordination, restoration, and oversight. Every motion must be considered in relation to the cargo below. Where will the cut be made? How will the mast be supported? How will vibration be minimized? What happens if weather changes? What if the metal behaves differently than expected? What if the underwater structure is not where models predicted? The public announcement sounds calm because public announcements are designed to sound calm. The engineering reality is one of controlled uncertainty. No one working there will treat the wreck as harmless. They will treat it as a structure that must not be surprised. The mast project has been discussed for years. A recommendation to remove or reduce the masts was announced earlier in the decade. Preparatory work and surveys were carried out. Then new information about the wreck and seabed created complications. The preferred method had to be reconsidered. This delay frustrated people who wanted action. But it also demonstrates why the wreck resists simple solutions. Plans made from models must survive contact with the actual seabed. A platform needs secure support. Equipment needs access. Weather windows matter. The masts are connected to degraded steel. The cargo beneath changes the acceptable margin for error. On an ordinary wreck, engineers might improvise when conditions differ from plans. On the Richard Montgomery, improvisation must be limited. The operation is not only a salvage project. It is a risk reduction project on top of an explosive ordnance site inside a busy estuary. That combination is rare. The delay therefore becomes part of the story. Britain did not suddenly discover the masts in 2026. It spent years deciding how to remove them without making the wreck more dangerous. And after the masts are gone, the hardest question remains. What comes next? The exclusion zone will remain. Monitoring will continue. The cargo stays aboard. The mast operation reduces one pathway to damage. It does not end the Richard Montgomery problem. There are several ways a major incident might theoretically begin, and responsible discussion requires care. A collision could disturb the wreck. An anchor could strike it. A heavy object could fall into a hold. Structural collapse could move cargo. Human interference could create impact or vibration. A fire involving exposed material could complicate the site. But listing possibilities can create a false sense that each is likely. The exclusion zone exists to reduce human causes. The masts are being removed to reduce one structural cause. Surveys track environmental causes. Risk management is the process of closing pathways one by one. This is why the government does not present the wreck as an uncontrollable bomb. The site is controlled. Not perfectly, but actively. The distinction matters because fear can become its own hazard. Sensational reporting can encourage unauthorized visits, conspiracy theories, or reckless attempts to investigate. It can also undermine trust when predicted catastrophe repeatedly fails to occur. The strongest documentary approach is not to shout that London is about to be destroyed. It is to ask a more interesting question. How does a modern state manage a wartime hazard that may remain dangerous longer than the institutions responsible for it? The Richard Montgomery is not frightening because explosion is certain. It is frightening because uncertainty must be managed indefinitely. Parliament has debated the wreck repeatedly. Questions focus on the quantity of explosives, the condition of the hull, emergency planning, shipping near the site, the credibility of official assessments, and whether government secrecy has hidden the true scale of the risk. These debates often reveal disagreement over numbers. Official figures use around 1,400 tons of explosive content. Some critics have argued from original manifests and salvage records that a larger total weight of munitions or explosive material may remain. The difference can sound like proof of concealment. It may also reflect different counting methods, explosive filling versus total munition weight, incomplete wartime records, recovered items, cargo lost from the wreck, and uncertainty about what remains inside inaccessible holds. The key point is not that the number is perfectly known. It is that the cargo is large under any credible estimate. A documentary should not pretend the most alarming figure is automatically the truest. Nor should it imply that uncertainty makes the official figure meaningless. The honest version is stronger. Britain knows a great deal about the wreck. It does not know everything. It has surveyed the structure for decades. It cannot inspect every munition. It has records. Those records are not perfect. The wreck is both one of the most monitored and one of the most uncertain objects in British waters. That contradiction keeps the story alive. The Isle of Grain sits to the southwest of the wreck. The area contains major energy and industrial infrastructure. This proximity has fueled some of the most dramatic disaster scenarios associated with the Richard Montgomery. Critics have imagined blast waves, water displacement, debris, fires, damage to storage facilities, and cascading disruption. Older assessments sometimes described enormous water columns or waves if the entire cargo detonated simultaneously. Those scenarios are difficult to translate into modern probability. A worst-case model asks what could happen under extreme assumptions. It does not necessarily describe what experts believe will happen. Still, the presence of industrial facilities matters. Risk is not only the wreck itself. Risk is the wreck plus its surroundings. A remote explosion and an explosion near shipping, storage, and communities are not equivalent. This is another reason the government's remote risk language can feel unsatisfying to residents. People do not live inside probability calculations. They live inside consequence zones. A 1 in a million event can sound comforting to someone far away. It can sound different if the event is outside your window. The Richard Montgomery therefore sits at the intersection of technical risk and public trust. Experts ask, how likely is a major detonation? Residents ask, what happens to us if you are wrong? Both questions are legitimate. Sheerness has lived beside the wreck longer than most people have been alive. The town's relationship with the sea is practical, not romantic. Dockyards, ships, naval history, ferries, industry, and coastal weather shape local identity. The Richard Montgomery became another feature of that maritime world. But it is a feature no one can visit. That gives the wreck a strange cultural status. It is visible but inaccessible. Historic but not safely explorable. American but embedded in British waters. A war relic still governed as a live hazard. The masts functioned like a monument no one intentionally built. They marked the place where a voyage ended, where salvage failed, and where policy became permanent. Local people may feel attachment to them even while understanding the danger below. That is why the government plans to preserve and display the masts after removal rather than scrap them. The steel has become heritage. Rust has become memory. The same structures once considered a hazard are being transformed into museum objects. This is a powerful ending within the larger story. The masts will leave the wreck for the first time since 1944. They will arrive on land. They will be cleaned, stabilized, and interpreted. People will stand close to them. But the part of the ship that matters most will remain beyond reach. The museum will preserve what Britain can safely remove. The estuary will keep what Britain cannot. The Richard Montgomery is also a story about the difference between wartime and peacetime. During war, urgency dominates. Cargo must move. Ships must sail. Anchorages must fill. Mistakes are absorbed into a much larger crisis. In peace, the same mistake becomes isolated and visible. The grounding in August 1944 was one accident among thousands of wartime losses. Britain was fighting for survival. Europe was still occupied. Men were dying across France. The government's immediate priority was ammunition, not the 80-year environmental and engineering consequences of a wreck. After the war, priorities changed. But the physical object did not reset. Peace inherited the hazard. This happens across former battlefields and industrial sites. Unexploded bombs remain beneath cities. Mines remain in fields. Chemical agents remain in dumps. Sunken vessels leak fuel. Military land holds contamination. Each generation inherits the decisions of a crisis it did not experience. The Richard Montgomery is unusually visible, but the principle is common. War creates long shadows. The people who authorize weapons often do not live long enough to manage their remains. The workers who loaded the bombs in America could not imagine British engineers cutting masts from the wreck in 2026. The sailors who abandoned the ship could not imagine sonar models comparing seabed change 80 years later. But their emergency became our maintenance program. The ship was American. The wreck is British. The cargo was meant for France. The war was global. This multinational identity is one reason the story works so well. The Richard Montgomery connects Florida shipyards to the Thames Estuary, American industrial production to British maritime control, and the Normandy campaign to a sandbank near Kent. It is Anglo-American history in physical form. The United States built the ship and loaded much of the cargo. British authorities directed the vessel inside the estuary. British salvors removed part of the ammunition. British agencies now manage the wreck. No single country owns the whole story. That complicates responsibility. Could the United States have been expected to remove its cargo after the war? Did ownership transfer? Who pays for intervention? Who bears liability if something happens? Over decades, practical responsibility settled on Britain because the wreck lies in British waters and threatens British interests. But symbolically, the ship remains American. That is why the 2026 government announcement calls it part of Anglo-American maritime heritage. The phrase is accurate. It is also incomplete. Heritage usually celebrates what nations achieve together. The Richard Montgomery preserves what they failed to finish together. There is a temptation to compare the wreck with the Halifax explosion of 1917. In Halifax, the French munition ship Mont Blanc collided with another vessel, caught fire, and exploded in the harbor, devastating the city and killing nearly 2,000 people. The event remains one of the largest non-nuclear explosions in history. The comparison is emotionally powerful. A munition ship. A harbor. A city nearby. But the situations are different. The Mont Blanc's cargo was involved in an active shipboard fire before detonation. The Richard Montgomery's cargo is submerged, dispersed within a broken wreck, and monitored inside an exclusion zone. The Halifax disaster shows what a large concentrated munitions cargo can do under catastrophic conditions. It does not prove the Richard Montgomery will repeat it. Still, the memory of Halifax explains why no responsible authority treats a bomb ship casually. History provides the fear. Engineering provides the distinctions. The documentary should hold both. A giant explosion is possible in the physical universe. It is not the expected outcome. The goal of management is to prevent the sequence of events that could make such an outcome credible. That is why the masts matter. A mast collapsing is not Halifax. But removing one possible initiating event reduces the space in which disaster could begin. Another comparison comes from the SS Keels. The Keels was a wartime ammunition wreck off Folkestone. In 1967, during salvage work, part of its cargo exploded underwater. The blast was detected like an earthquake, damaged property, and produced a dramatic plume. The Keels carried less explosive material than the Richard Montgomery. That event became a warning about intervention. It showed that submerged wartime munitions could still detonate decades later. It also showed that salvage itself can create the conditions for explosion. This comparison is more relevant than most sensational nuclear analogies because it involves an old ammunition wreck and a recovery operation in British waters. But again, the lesson is not that every wreck will explode. The lesson is that disturbance must be treated seriously. The Richard Montgomery's management policy evolved inside the shadow of such precedents. Engineers cannot assume age has neutralized the cargo. They cannot assume water makes every fuse harmless. They cannot approach the wreck as if it were ordinary scrap. The keels turned a hypothetical danger into historical evidence. Old bombs can still act like bombs. That is why the Richard Montgomery's masts will be cut with years of planning behind every movement. The Thames itself adds mythology to the story. People hear bomb ship beneath the Thames and imagine a wreck near Westminster, Tower Bridge, or the Thames Barrier. In reality, the Richard Montgomery lies in the outer estuary near Sheerness, far downstream from central London. That distance matters. Claims that a blast would destroy London are generally exaggerated. But the phrase approaches to London remains strategically true. The estuary is the maritime gateway to the capital and to major ports and infrastructure. The wreck therefore sits close enough to London to gain national attention, but far enough away that many Londoners have never heard of it. This creates an unusual geography of fear. Local people see the masts. National audiences see an alarming map. International viewers hear that an American bomb ship is buried near Britain's capital. Each audience imagines a different danger. The most responsible script should correct the misconception without weakening the hook. The Richard Montgomery is not under London. It is not expected to destroy London. It is, however, a massive wartime munitions wreck in a critical estuary connected to London and surrounded by communities and industrial activity. The truth is dramatic enough. What would happen if one munition detonated? The answer depends on where it is, what surrounds it, and whether the explosion propagates to nearby weapons. A single bomb could damage the wreck without producing a full cargo detonation. It could scatter debris. It could disturb other munitions. It could create a local water plume and shock wave. The most serious scenario would involve sympathetic detonation, where one explosion triggers others. But the probability of large-scale propagation through a corroded, flooded, dispersed cargo is difficult to establish publicly. This uncertainty is exactly why officials avoid simple predictions. They do not say nothing could happen. They do not say everything would explode at once. They model possibilities. They monitor conditions. They reduce triggers. The public often wants a binary answer. Safe or dangerous? Remove or leave? Explode or never explode? The wreck refuses binaries. It is dangerous enough to regulate. Stable enough to leave. Deteriorating enough to intervene selectively. Uncertain enough to keep studying. The Richard Montgomery is a lesson in how real risk rarely matches the clean categories demanded by headlines. The warning buoys around the wreck form a circle of absence. Ships move around them. Fishing boats keep distance. Charts mark the prohibited area. Radar watches for entry. Inside the circle, the tide continues working on the hull. Outside the circle, ordinary life continues. This boundary is one of the strongest visual devices in the story. A ring on the water created by law around a broken ship created by war. The exclusion zone is not large compared with the estuary, but it changes the behavior of everyone who navigates nearby. It makes the wreck present even when it cannot be seen. After the masts are removed, the buoys will become even more important. They will be the visible warning. Without the rusted steel above the tide, a casual observer may see only water. That is the strange future of the Richard Montgomery. The wreck will become less visible at the moment government activity around it becomes more sophisticated. The landmark disappears. The management remains. The sea closes over the last vertical pieces of the ship. But the legal circle stays open on every chart. The masts are being removed partly because gravity never stops. For decades, their weight has pressed through corroding connections into the ship's deck and structure. Wind and tide apply force. Metal thins. Supports weaken. A mast that was stable last year may lean more next year. If one collapsed unpredictably, it could fall onto the deck or into an area connected with the cargo holds. That does not mean collapse would detonate the bombs. It means collapse would create an uncontrolled impact, and uncontrolled impacts are precisely what risk managers try to eliminate. Removing the masts converts an uncertain future event into a planned present operation. That is the logic. But planned does not mean simple. To cut a mast safely, engineers must support it before separation. They must control the cut section, prevent sudden movement, manage underwater visibility, account for tides, and lift the steel without dropping it. Every piece of equipment becomes part of the risk model. The platform, the cutting tools, the lifting gear, the vessel above, the weather forecast, the emergency plan. The mast project is therefore a controlled argument with gravity. Britain is acting before gravity chooses the timing. The historic dockyard Chatham is an appropriate destination for the masts. Chatham once built and supported ships for the Royal Navy. It represents centuries of British maritime power, industrial skill, and war preparation. The Richard Montgomery's masts will enter that historical landscape as objects from a different kind of naval story. They were built in America. They belonged to a merchant cargo ship. They never reached battle. They spent most of their existence fixed above a wreck. At Chatham, conservators will face a new problem. Steel removed from salt water can deteriorate quickly if not treated properly. Decades of corrosion do not stop because an object reaches land. The masts must be stabilized, documented, and preserved. This is another transformation. Military equipment becomes hazard. Hazard becomes landmark. Landmark becomes museum artifact. The public may eventually see the masts closer than anyone has safely seen them in generations. Children will stand beside them. Visitors will read the cargo figure. The object that once warned ships away will invite people closer. But the museum display should preserve the central contradiction. These masts are not the ship. They are the pieces Britain could remove without opening the holds. The wreck's annual surveys create a strange archive. Each report captures the Richard Montgomery in another year of decay. A new sonar model. A changed sediment pattern. A missing plate. A shifted section. A mast angle. A crack. A comparison with the previous survey. The language is technical because technical language controls emotion. It turns a frightening object into measured geometry. This is useful. It is also haunting. The reports document the slow disappearance of a ship that cannot be allowed to disappear unpredictably. Normally, archaeologists accept that shipwrecks decay. Wood collapses. Metal corrodes. Sediment covers structures. The sea reclaims them. The Richard Montgomery is different because decay may change risk. Preservation is not the goal in the usual sense. Stability is. The government does not need the hull to look like a ship. It needs the hull to avoid disturbing its cargo. This produces a paradox. Some decay may bury and isolate munitions. Other decay may expose or move them. The same sediment that hides danger can support the wreck. The same tide that erodes one area can cover another. The seabed is not a passive flaw. It is part of the structure. That is why surveys include the environment around the ship, not just the steel itself. There are stories of near misses around the wreck. Ships navigating the estuary have approached marker buoys. Anchors and routes have raised concerns. Over the decades, authorities have strengthened charting, surveillance, and response procedures. A modern commercial vessel is vastly larger than many ships sailing when the Richard Montgomery sank. A collision with the wreck or exclusion infrastructure could create danger even without direct contact with the cargo. This makes navigation control essential. The wreck lies near, but outside, normal movement. Pilots know it. Port authorities watch it. Modern radar and vessel tracking make accidental intrusion less likely than it was decades ago. But maritime systems are never perfect. Human error, mechanical failure, weather, and misunderstanding remain possible. The wreck's location cannot be changed. So behavior around it must be managed permanently. That is another way the Richard Montgomery continues to shape the estuary. It is not merely an object. It is a rule. Do not enter. Do not anchor. Do not dive. Do not salvage. Do not touch. The ship has been dead since 1944. Its instructions remain active. Some viewers will ask whether saboteurs could target the wreck. Authorities have considered security as part of site management, which is one reason surveillance and exclusion matter. But the wreck should not be described as an easy weapon waiting to be activated. Its cargo condition is uncertain, access is controlled, and any attempt to interfere would be extraordinarily dangerous. The more important point is broader. Hazards attract imagination. A secret base attracts trespassers. A forbidden island attracts explorers. A bomb ship attracts people who want to prove the government wrong, capture dramatic footage, or create fear. That human curiosity can become part of the risk. Responsible storytelling should not provide operational detail about approaching or disturbing the wreck. It should emphasize that the exclusion zone is legal, active, and justified. The mystery belongs in the history. The wreck does not need amateur investigation. The Richard Montgomery has survived 82 years partly because most people have respected the boundary. The danger is not only what the bombs might do. It is what people might do around bombs they do not understand. The captain's role in the grounding has been debated since 1944. Was he warned in time? Why did the ship not respond sooner? Was the anchorage appropriate for a deeply loaded vessel? Did harbor control place the ship too close to shallow water? Was weather the decisive factor? A wartime inquiry examined the incident, and the captain returned to duty. This suggests blame was not placed entirely on him. That matters because disaster stories often search for one person to carry responsibility. A sleeping officer. A mistaken order. A bad anchorage. A delayed warning. But complex accidents rarely belong to one person. The grounding emerged from a system, crowded wartime waters, heavy cargo, anchorage decisions, communication, weather, tide, ship design, and human response. Focusing only on the captain makes the story smaller than it is. The Richard Montgomery was created by industrial systems and lost inside a maritime system. The continuing hazard exists because of a policy system. No single villain explains 82 years of bombs under the Thames. The deeper question is how systems manage mistakes once blame no longer solves anything. The salvage workers deserve a place at the center of the story. They entered a ship loaded with explosives while the hull was cracking and flooding. Their work recovered a huge quantity of ammunition. Without them, far more material might remain. Yet their names are rarely remembered outside specialist histories. This is common in logistical disasters. Captains and officials appear in reports. Workers appear as numbers. But the salvage operation depended on human beings handling bombs one by one, crate by crate, lift by lift. They worked under wartime pressure. Some accounts note disputes over danger pay, an almost absurd detail given the conditions. Whether every version is accurate or not, the contrast captures the culture of wartime labor. Extraordinary risk could be treated as ordinary duty because the nation needed the job done. The workers stopped only when continuing became too dangerous. That decision saved lives. It also left the modern problem. There is no contradiction. Sometimes the correct decision in one moment creates a difficult inheritance for another. The salvage crews did not fail because bombs remained. They succeeded in removing what they could before the ship became a tomb. The Richard Montgomery never exploded during the grounding. That fact is easy to overlook. The hull cracked. The ship flooded. Cargo shifted. Salvage workers moved thousands of items. The vessel broke apart. Storms passed. Tides moved. Decades of corrosion followed. And still, no major detonation occurred. This history supports the official view that the wreck is stable and the probability of explosion is low. But it can also create complacency. Survival is not proof of permanent safety. A bridge may stand for decades before one critical failure. A slope may remain stable until erosion changes its geometry. A corroded support may carry weight until the final cycle. Past stability is evidence. It is not a guarantee. This is why the mast operation is important. Authorities are not waiting for visible crisis. They are acting on a projected future risk. That is what competent prevention looks like. The public rarely sees prevention because successful prevention produces no event. If the masts are removed safely and nothing happens, some people will say the concern was exaggerated. But nothing happening is the purpose. The 2026 operation will happen under conditions the original crew could never have imagined. Remote sensing. Three-dimensional sonar models. Modern cutting systems. Specialist explosive ordnance analysis. Digital weather forecasts. Real-time communications. Emergency coordination among multiple agencies. The technology is vastly better. The physical problem is worse. The ship is older. The steel is thinner. The structure is more fragmented. The cargo condition is less certain. This is the paradox of delayed intervention. Capability improves. The object deteriorates. At some point, those lines cross. The MAST project suggests British authorities believe modern capability has finally reached a point where selective removal is safer than continued waiting. But the same logic may not apply to the cargo. Removing masts is one engineering problem. Emptying holds is another order of magnitude. The technology that can safely solve the visible problem may still not justify solving the hidden one. The Richard Montgomery therefore becomes a staircase of intervention. First monitor. Then trim rigging. Then remove masts. Perhaps one day stabilize other structures. Perhaps one day reconsider cargo. There may never be one final operation. The wreck may be managed in pieces until the sea and sediment create a new equilibrium. Could the wreck simply be encased? Engineers have considered many types of conceptual solutions over the decades: partial removal, stabilization, containment, controlled detonation, burial, structural reinforcement, or continued monitoring. Each creates new problems. Encasing a wreck changes seabed loading and water flow. Building around it requires construction close to munitions. Controlled detonation would deliberately create the event management is designed to prevent, though under planned conditions. Removing cargo exposes workers. Leaving cargo accepts deterioration. There is no clean option because the original clean option disappeared in September 1944 when salvage ended. This is a key narrative turn. The Richard Montgomery is not awaiting an obvious solution that timid officials refuse to use. It is a problem in which every solution contains its own hazard. That does not excuse delay forever. It explains it. The best management strategy may change as the wreck changes, technology improves, and surrounding infrastructure evolves. The correct answer in 1970 may not be the correct answer in 2026. The correct answer in 2026 may not survive another 30 years. The ship is static on the chart. The decision environment is moving. The bombs aboard the Richard Montgomery were designed to be dropped from aircraft or used in war. They were not designed to become archaeological objects. Their casings, explosive fillings, fuses, and packaging belonged to a specific military system. They had storage requirements, handling procedures, intended targets, shelf lives. The wreck destroyed that system. Labels disappeared. Racks collapsed. Water entered. Time became the main chemical process. This is why the cargo cannot be understood only by reading the original manifest. The manifest describes what was loaded. It does not describe what exists now. An aircraft bomb in 1944 and the corroded remains of that bomb in 2026 are related but not identical hazards. Some mechanisms may no longer function as designed. Some materials may be degraded. Some compounds may remain energetic. Some items may be buried in sediment and effectively isolated. Others may be exposed. The cargo has become a new object created by history. Explosive ordnance specialists must reason from both original design and present condition. The past tells them what might be there. The wreck tells them what time has done. White phosphorus has appeared in some historical discussions of the wreck because certain munitions can release material that ignites when exposed to air. Reports of burning material on the water have contributed to the ship's mythology. A flame appearing on the surface near a wreck full of bombs is a perfect nightmare image. But the interpretation of such incidents requires evidence. Marine environments contain many sources of unusual fire, pollution, and debris. Not every story can be verified decades later. The responsible point is that different munitions create different hazards. High explosives, detonators, incendiary materials, and chemical contents do not behave the same way. The cargo is not one uniform block. That diversity complicates salvage and risk assessment. It also complicates storytelling. A single dramatic label, 1,400 tons of bombs, hides thousands of objects with different sizes, materials, and conditions. The wreck is less like one bomb than a damaged warehouse filled with many kinds of wartime ordnance. That makes a total simultaneous detonation less simple than headlines suggest. It also makes intervention more complex than removing one device. The Richard Montgomery sits inside a broader British landscape of unexploded war. Construction projects in London still uncover German bombs. Fishermen recover munitions from the sea. Former military ranges contain buried ordnance. Coastal waters hold wrecks loaded with fuel, ammunition, and weapons. The Second World War remains physically present beneath modern Britain. Most discoveries are dealt with locally by bomb disposal teams. The Richard Montgomery is different because the scale and location make it permanent. It cannot be cordoned off for one afternoon and removed by a small team. It has its own legal zone, survey history, policy framework, and public mythology. In that sense, it is less like one unexploded bomb and more like a national institution. Departments inherit it. Budgets include it. Experts build careers studying it. Reports accumulate. The wreck outlives political administrations. A new minister can announce a project, but the ship was there before the minister was born and may remain after the minister leaves office. This is what makes the story larger than maritime history. It is about how states inherit physical obligations from wars long after memory becomes ceremony. The masts have been visible for 82 years. That number matters because it converts metal into generations. People who were children when the wreck sank became grandparents while the masts remained. Their children saw the same 3 lines above the water. Their grandchildren saw them too. The wreck became a stable reference point in family memory even as the hull below became less stable physically. When the masts are removed, some local people may feel relief. Others may feel loss. A landmark can be dangerous and beloved at the same time. The government's decision to preserve the masts acknowledges that emotional complexity. But once displayed on land, the masts will tell a curated story. At sea, they meant warning. In a museum, they may mean sacrifice, engineering, and heritage. Curators will choose photographs, dates, explanations, and objects. The chaotic uncertainty of the wreck will become an ordered exhibition. That is what museums do. They turn danger into narrative. The bombs below will resist that transformation. They remain uncurated history. There is one more question the story should ask. Why did this particular wreck become famous when thousands of wartime wrecks remain largely unknown? The answer is visibility. The masts rose above water. The cargo figure was enormous. The location was near towns and major shipping. Government monitoring produced records. Journalists could film the site from a distance. The phrase bomb ship needed no explanation. Most underwater hazards are abstract. The Richard Montgomery had a silhouette. It gave fear a shape. The 2026 mast removal may change that. Future documentaries will rely more on archive footage, sonar imagery, maps, and museum displays. The living landmark will be gone. This creates urgency for the story. The final summer with all 3 masts above the water marks the end of one era. After September, the wreck may look like empty sea. But empty sea can hold more history than a monument. A high-retention version of the story should return repeatedly to the visible and invisible. Visible, 3 masts. Invisible, 1,400 tons of explosives. Visible, warning buoys. Invisible, corroded cargo holds. Visible, engineers on a platform. Invisible, the exact condition of each bomb. Visible, a museum display in Chatham. Invisible, the wreck continuing to deteriorate offshore. This contrast keeps the story moving because every answer reveals another hidden layer. The viewer first sees a harmless landmark. Then learns it is a ship. Then learns it is American. Then learns it carries bombs. Then learns half the cargo was salvaged. Then learns the ship broke apart. Then learns the government watches it constantly. Then learns the risk is officially remote. Then learns Britain is spending millions to remove only the masts. Each reveal creates a new question. Why did it sink? Why were the bombs left? Why not remove them now? Why do officials call it stable? Why remove the masts? What happens after they are gone? The story does not need invented conspiracy. The documented contradictions create enough suspense. The operation in September will likely be slow rather than cinematic. There may be no dramatic blast. No evacuation of London. No heroic diver carrying a bomb to safety. Instead, viewers may see specialist vessels holding position, workers preparing equipment, sections of steel being cut and lifted, and weather delays. This is good. The suspense comes from restraint. Everyone involved will be trying to make the event look uneventful. That is what safety looks like. The top of a mast rises from the water. A crane takes the weight. Metal separates. The section is lifted. Nothing else moves. Then the process repeats. The drama is in what does not happen. The wreck does not shift. The deck does not collapse. The cargo does not react. The sea remains ordinary. If the project succeeds, Britain will have reduced risk without touching the bombs. That may sound anticlimactic. It is actually the perfect conclusion to an 82-year engineering problem. Not victory. Not final resolution. One dangerous thing removed safely. The larger danger left under control. After the operation, the Richard Montgomery will enter a new phase. Without the masts, above-water inspection will change. Warning signs will need other forms. The legal exclusion zone will stay in force. Radar surveillance will continue. Annual or regular surveys will still compare the hull and seabed. The public may hear less about the wreck because the familiar landmark is gone. That creates a risk of cultural forgetting. Visible hazards stay in public memory. Invisible hazards become administrative. The ship may disappear from photographs while becoming more dependent on technical monitoring. This is why preserving the masts matters beyond tourism. They will carry the story onto land. They will remind future visitors that the estuary still holds the rest of the ship. But a museum artifact can also create false closure. People may assume the wreck has been made safe because the famous masts were removed. The script should be clear. Mast removal is risk reduction. It is not bomb removal. Approximately 1,400 tons of explosives will remain in the forward holds after the project, according to the official figure. The war cargo will still be there. The problem will simply become harder to see. Could the wreck remain for another 80 years? Possibly. But not unchanged. Steel does not stop corroding. Sediment does not stop moving. Channels evolve. Shipping changes. Sea levels and storm patterns change. Industrial activity around the estuary changes. Technology changes. Risk policy changes. The future of the wreck may be a long sequence of smaller interventions rather than one final salvage. A plate stabilized. A structure removed. A seabed area monitored more closely. A new exclusion system. A future generation deciding that cargo removal has become safer than continued decay. Or a future generation deciding the opposite. The Richard Montgomery may never have a clean ending. Some historical objects do not conclude. They become obligations. That may be the most unsettling truth in the story. The ship did not sink into the past. It sank into the future. The title "The Bomb Ship Beneath the Thames That Could Still Explode" is designed to create urgency. But the voiceover should earn trust by correcting its own drama. The ship is in the Thames Estuary, not beneath central London. A major explosion is considered remote. The cargo is not a nuclear weapon. No countdown is known. The mast operation is planned as a safe reduction of structural risk. These corrections do not weaken the story. They strengthen it. Because the true mystery is better than the exaggerated one. Britain has spent 82 years managing a massive American munitions wreck near one of its busiest maritime regions. The ship remains because removing the danger could be more dangerous than containing it. The government is now willing to cut away the last visible structures while leaving the main cargo untouched. That is a real contradiction. It needs no false tsunami heading toward Parliament. The truth is an engineering thriller. A broken ship. A hidden arsenal. A government choosing the exact amount of movement it can safely allow. The anchorage decision reveals how small margins can create long disasters. The Richard Montgomery was deeply loaded. The water at the assigned anchorage offered little clearance beneath the ship. In calm conditions, that might have been manageable. In worsening weather, with anchor movement and tide variation, the margin became dangerous. Modern navigation systems make it easy to imagine that wartime harbor control should have known exactly where every ship sat. But 1944 operations depended on charts, signals, visual observation, radio, experience, and human coordination under extraordinary traffic pressure. The estuary was not a quiet commercial harbor. It was part of an invasion supply system. Ships arrived faster than ports could process them. Convoys formed and dissolved. Naval priorities changed. Weather interfered. One vessel could be ordered to wait while another received priority. Inside that system, the Richard Montgomery's anchorage may have looked like a temporary inconvenience rather than a historic risk. The disaster did not begin with a bomb. It began with insufficient water beneath a ship. That is an important lesson. Catastrophic legacies often begin with ordinary operational decisions whose consequences no one can yet see. The cargo loading process in America also deserves attention. Thousands of munitions did not appear aboard the ship automatically. They moved through factories, rail yards, depots, trucks, docks, cranes, and stevedore teams. Workers checked markings, handled crates, followed wartime procedures, and filled the holds according to loading plans. Many of those workers were civilians. Women and men across the United States entered industrial jobs transformed by war. They built ships, filled shells, assembled aircraft, packed supplies, and loaded cargo. Their labor connected American communities far from the front to battles overseas. The Richard Montgomery carried that labor inside its holds. Each bomb represented metal mined, explosives manufactured, casings machined, components inspected, and transport organized. The cargo was a compressed form of national industry. When the ship grounded, the loss was not only military material. It was thousands of hours of human work trapped in a steel hull. Today the same cargo is discussed mainly as hazard. But it began as effort. That shift, from essential weapon to unwanted explosive waste, is one of the quiet tragedies of war logistics. The wreck's legal status changed in the 1970s when Britain used the Protection of Wrecks Act to designate the site. This was not heritage protection in the ordinary sense. Many protected wrecks are guarded because of archaeology, human remains, or historical importance. The Richard Montgomery is protected because entry itself could be dangerous. The law transforms the sea around the ship into controlled territory. A line drawn through coordinates becomes enforceable even though no fence can be built in water. This is a fascinating example of law interacting with geography. The wreck is physically broken but legally intact as a hazard zone. The tide crosses the boundary. Fish cross it. Sediment crosses it. People and vessels may not. The exclusion zone therefore exists as an invisible wall. Charts make it visible to navigators. Buoys translate it into physical warning. Radar turns it into a monitored space. The law does what the ship's hull can no longer do. It contains the cargo by controlling the world around it. The government survey reports create continuity across political time. A prime minister may serve a few years. A minister may hold a transport brief for months. A contractor may change. But the survey sequence continues. This continuity is essential because the wreck changes slowly. One inspection cannot establish a trend. Engineers need comparison over years. How fast is a crack widening? How quickly is a mast leaning? Whether seabed support is disappearing? Whether debris is migrating? The true intelligence is in the difference between models. A single sonar image may look chaotic. 2 images separated by a year reveal movement. 10 years reveal a pattern. This makes the Richard Montgomery a long-duration engineering study as much as a wreck. The government is not simply asking whether the ship is dangerous today. It is asking how the danger is evolving. That question requires institutional memory. If records are lost, methods change without calibration, or funding gaps interrupt surveys, the wreck becomes harder to understand. Monitoring is therefore not passive. It is a knowledge system that must be maintained as carefully as the buoys. Weather remains a major actor in the story. A gale contributed to the original grounding. Storms and tides have shaped the wreck ever since. Weather will also determine whether the mast removal project proceeds on schedule. Marine operations require acceptable wind, wave, current, and visibility conditions. A vessel must hold position. A suspended mast section must remain controlled. Divers or remotely operated equipment must work inside planned limits. This means the project may stop even when the public sees no dramatic storm. A moderate change in current can matter underwater. A swell can affect lifting. Wind can change the behavior of a crane vessel. Forecasting reduces uncertainty but cannot eliminate it. The sea has governed the Richard Montgomery from the beginning. It moved the anchor, supported and exposed the hull, carried sediment, corroded steel, and now it will decide which days engineers are allowed to work. The government can fund the project. Experts can design it. But the estuary still has veto power. The ship's split hull creates separate zones of concern. The forward section contains the main remaining explosive cargo. Other parts of the vessel lie differently supported and differently exposed. This fragmentation complicates both mapping and intervention. A wreck is not frozen at the moment of sinking. Sections settle. Frames detach. Decks collapse. Cargo openings change. Debris fields grow. The sea reorganizes the ship. This is why old diagrams cannot be treated as present reality. The original plans show where holds, bulkheads, and masts were designed to be. Surveys show where structures are now. The difference between design and ruin is where risk lives. An engineer must understand both. What was connected? What is still connected? What load path carries mast weight into the deck? What happens when that path is cut? The mast removal design depends on answering questions about a ship that no longer behaves like a ship. It behaves like a corroded landscape. The title Liberty Ship sounds noble, but the vessels were born from necessity rather than romance. They were cargo boxes with engines, built to survive enough voyages to justify their cost. Their crews faced submarines, storms, collisions, mechanical failures, and long hours in convoy. Merchant seamen died in large numbers during the war, often without the recognition given to naval combatants. The Richard Montgomery's crew survived the grounding, which is one reason the story focuses on bombs rather than people. But the ship still belongs to merchant mariner history. Its officers had to navigate crowded waters. Its engineers kept machinery running. Its deck crew handled anchors and lines. Its radio operators listened for instructions. Its cooks fed men carrying a cargo capable of destroying them. The ship was a workplace before it became a hazard. Remembering that keeps the story human. The masts did not rise from an empty machine. They once stood above a crew that expected to reach France. The failed final journey also creates a powerful counterfactual. If the Richard Montgomery had anchored safely, the convoy might have formed. The ship might have crossed the channel. Her cargo might have been unloaded at Cherbourg. The bombs might have been used, stored, or moved onward. The vessel might have completed more voyages or been scrapped after the war. No exclusion zone. No 80 years of surveys. No museum masts. No bomb ship beneath the Thames. A movement of a few hundred yards separated ordinary wartime service from a national hazard. This is why shipwreck stories feel fated even when they are not. After the event, every earlier decision appears to point toward the sandbank. Before the event, it was simply another day in a crowded anchorage. History creates inevitability backward. The Richard Montgomery reminds us that most disasters are accidental until the moment they become permanent. Local memory often preserves details official history smooth away. Residents remember particular flames, warnings, survey vessels, storms, rumors, and government announcements. Fishermen remember where they were told not to go. Families remember parents pointing toward the masts. Newspapers preserve periodic scares. Not every memory can be verified. But memory matters because it shows how people live beside uncertainty. Official reports describe stable condition and remote risk. Local stories describe a forbidden ship full of bombs. Both are ways of making the hazard understandable. The expert language reduces panic. The folklore keeps attention alive. If the masts disappear and the folklore weakens, official monitoring becomes even more important because public memory may no longer reinforce caution. The wreck's future is therefore partly cultural. A danger forgotten by the public must still be remembered by institutions. The Chatham Conservation Project can become a story within the story. Once removed, the masts will carry salt, marine growth, corrosion products, weakened sections, and decades of exposure. Conservators will document their condition and choose methods to slow further decay. The process may take years. Visitors could watch the objects change from hazardous marine steel into stable exhibits. Conservation is a form of controlled time. The sea accelerated deterioration. The museum attempts to slow it. This is the opposite of what happens offshore. At the wreck, time remains the enemy. At Chatham, time becomes the subject. The masts may eventually outlast more of the ship than anyone expected. They will survive because they were removed from the environment that made them famous. The bombs cannot follow. The decision to display the masts locally also reflects a politics of ownership. Who has the strongest claim to the objects? The United States built the ship. Britain manages the wreck. Kent and the Medway communities live beside it. Chatham has maritime conservation expertise. A national museum might reach a larger audience, but a local display keeps the story connected to the estuary. This matters because heritage can be extracted from communities just as artifacts are extracted from sites. The government appears determined to avoid turning the masts into distant trophies. Keeping them in Kent says the wreck belongs to local memory as well as national history. Yet the masts will also tell an international story of American production and Allied logistics. The best exhibition will hold all these identities together rather than choosing one. The Richard Montgomery also sits inside the history of welded ships. Welding allowed faster construction than traditional riveting and reduced weight. It was essential to mass production. But early welded hulls sometimes suffered brittle fracture and crack propagation, particularly under cold conditions and stress concentration. Liberty ship failures led to major advances in fracture mechanics, metallurgy, design, and inspection. Engineers studied why some hulls cracked and how to prevent similar failures. The Richard Montgomery structural collapse therefore belongs to a wider technological learning process. The same war that demanded ships faster than ever also accelerated understanding of why ships fail. Modern engineers approaching the wreck inherit that knowledge. They know more about fracture than the builders did. But they are working with the result of an old fracture after 80 years of corrosion. The ship became both casualty and teacher. The cargo figure of 1,400 tons should be explained visually rather than compared carelessly with nuclear weapons. Imagine hundreds of large aircraft bombs. Imagine cargo holds filled with metal cylinders, fins, casings, crates, and components. Imagine the weight pressing downward as the tide leaves the ship partly unsupported. Imagine half the cargo removed and the rest disappearing beneath dark water. This image is more accurate than a single giant explosive block. The munitions are separate objects. Their arrangement matters. The wreck structure matters. Water and sediment matter. The danger comes from a system of objects, not one device. That complexity is precisely why the ship cannot be given a simple explosive equivalent. A documentary earns credibility by resisting the easiest comparison. The phrase stable condition also deserves translation. Stable does not mean intact. It does not mean corrosion has stopped. It does not mean the ship is safe to enter. It means surveys have not found changes that experts believe indicate imminent major failure, and that the wreck's evolution remains within monitored expectations. A stable ruin can still be deteriorating. A stable slope can still erode. A stable patient can still require intensive observation. This distinction helps explain why mast removal and stable condition language are not contradictory. The wreck can be stable overall while one component creates growing long-term concern. Removing that component may preserve overall stability. The public hears stable as reassurance. Engineers hear it as a current state that must be maintained. Emergency planning around the wreck is necessarily difficult. A large incident could affect water, air, shipping, roads, ports, and nearby communities. Response plans would involve multiple authorities and would depend on the scale and type of event. But detailed emergency procedures are not the same as public predictions. Governments may prepare for scenarios they consider highly unlikely because preparedness is part of responsible risk management. This creates another public misunderstanding. If emergency services plan for a major explosion, some assume officials secretly expect one. If officials say the risk is remote, others assume planning is unnecessary. Both are wrong. Low probability, high consequence hazards require plans precisely because improvisation would fail if the event occurred. The existence of a plan is not proof of expected disaster. It is proof that consequences matter. The estuary's changing climate may eventually affect the wreck. Sea level rise, altered storm patterns, stronger surges, and changes in sediment transport could modify seabed conditions over decades. Predicting local effects is complex, but the broader principle is clear: the environment surrounding the ship is not fixed. This adds a new dimension to long-term management. The wreck originated in wartime weather. Its future may be shaped by climate conditions the original planners could not imagine. Surveys therefore become not only a record of corrosion but a record of environmental change. The Richard Montgomery is anchored to one place while the physical context around it evolves. Long-duration hazards force governments to plan beyond normal political horizons. A decision today may need to remain effective under a different estuary 50 years from now. There is an almost absurd contrast between the ship's short active life and long afterlife. Built in 1943. Grounded in 1944. Monitored into the 2020s. The wreck has existed roughly 80 times longer than its operational career. Most ships are remembered for voyages. This one is remembered for stopping. Most cargo is valuable because it moves. This cargo became dangerous because it did not. The Richard Montgomery is a monument to interrupted logistics. Everything about it was designed for motion: hull, engine, holds, convoy route, destination. Then movement ended and management began. That reversal provides one of the cleanest truths in the story. The ship failed to deliver its cargo. The cargo delivered the ship into history. Then Britain discovered that the ship was safer as a wreck than as a salvage project. That sentence captures the central paradox. The normal response to a dangerous cargo is removal. Here, removal itself creates danger. The normal response to a deteriorating structure is repair. Here, repair requires approaching explosives. The normal response to a wreck in a shipping area is clearance. Here, clearance may be worse than containment. Every ordinary solution turns inside out. That is why the Richard Montgomery has survived as a policy problem for 8 decades. It is not ignored because no one knows what to do. It remains because experts know exactly how many things could go wrong. The story should also ask what safe means to different people. To a government engineer, safe may mean risk reduced below a defined threshold. To a harbor operator, safe means vessels stay outside the zone. To a resident, safe may mean the bombs are gone. To a politician, safe may mean no incident and no panic. To a historian, safe may mean the site is preserved without injury. To a contractor, safe means the operation follows planned procedures. These definitions overlap but are not identical. This is why public debate can sound like people are arguing about facts when they are sometimes arguing about acceptable risk. The government says the wreck is managed safely. A resident may answer that a wreck containing 1,400 tons of explosives can never feel safe. Both statements can coexist. The disagreement is about tolerance, not only probability. After the masts are removed, new imagery may reveal the wreck differently. Sonar models, underwater photography, remotely operated vehicles, and archival film can replace the skyline view. The public may begin seeing the Richard Montgomery as a 3-dimensional ruin rather than 3 sticks above water. This could improve understanding. The masts simplify the story but hide the scale of the broken hull. A detailed model can show how the ship lies across the tide, where sections separated, how the seabed supports the structure, and why intervention is difficult. The challenge is presenting technical imagery without creating false certainty. A beautiful digital model can look complete even when internal cargo conditions remain unknown. Visualization reveals. It can also disguise uncertainty. The best documentary should show both the model and the gaps inside it. The ship's final destination, Cherbourg, adds emotional contrast because the port itself recovered. German demolition teams had damaged Cherbourg extensively before surrendering. Allied engineers cleared obstructions, repaired facilities, and restored operations. The port became useful again. The Richard Montgomery did not. One piece of the supply system was repaired under fire. Another remained broken in relatively sheltered water. This is not because Cherbourg's challenge was easier. It is because urgency changes what societies are willing to risk. During active war, engineers entered ruined ports because armies needed supplies immediately. After victory, the political justification for risking lives around an ammunition wreck weakened. Peace saved workers from a dangerous salvage. It also removed the urgency that might have finished the job. The sea has preserved and destroyed the Richard Montgomery at the same time. Water prevents ordinary atmospheric corrosion in some ways while enabling electrochemical corrosion in others. Sediment protects buried areas while placing uneven pressure on structures. Marine growth covers surfaces while adding weight and hiding damage. Tides clear debris while undermining support. The wreck exists because the sea received it. The wreck deteriorates because the sea never stops touching it. This dual role is another recurring motif. The water is both container and force. It keeps the bombs away from ordinary human contact. It also changes the ship that contains them. A final question should remain unanswered. Will Britain ever remove the cargo? No public schedule promises that. The Mast project does not commit the government to full clearance. Future decisions will depend on surveys, technology, cost, risk, and political judgment. It is possible the bombs will remain until the wreck collapses into sediment and the hazard becomes more dispersed. It is possible a future intervention will remove or neutralize them. It is possible management will continue for generations. The uncertainty is not a failure of the story. It is the ending. The Richard Montgomery is not a solved mystery. It is a live policy handed from one generation to the next. The closing should return to the three masts. For generations, they rose from the estuary at every tide. They told sailors where not to go. They told local people the wreck was still there. They gave an invisible cargo a visible marker. In September 2026, specialist engineers are expected to remove them one by one. The first mast will be supported, cat, lifted, taken away. Then the second. Then the third. For the first time since 1944, the horizon may no longer show the Richard Montgomery. The sea will look empty. But beneath it, the ship will remain split across the sandbank. The forward holds will remain loaded. The exclusion buoys will remain. The radar will remain. The surveys will continue. The war will still be there in physical form, waiting beneath ordinary water. The Richard Montgomery left Florida in 1944 carrying bombs for Europe. It crossed the Atlantic. It entered the Thames. It missed the war by a few miles and a few weeks. The soldiers advanced. Cherbourg reopened. Germany surrendered. The bombs never arrived. And 82 years later, Britain is still deciding how much of the ship it dares to move. The masts will become history. The cargo will remain a question.